Imagine searching for a file on your computer. One way to do this would be to manually open and check folders until you find what you're looking for. This can be time-consuming, but fortunately, you can use the search function to do this for you. If a file isn't found in the first folder, the search will restart in a different folder. Once the file is located, the search will end. This process represents an example of recursion. In this video, you'll learn about recursion and what it is, how recursion is different from other types of loops, and recognize the 4 types of recursions. At Little Lemon, all cooks share their recipes in a folder system. The top folder is called Recipes. This folder contains all the subfolders for menu categories, including appetizers, main courses, desserts, and so on. If you go into appetizers, you'll find an additional level of folders for hot and cold dishes. So how do the cooks find the recipes they're looking for? And how do they know if they have searched all the folders if they can't find a specific recipe? One of the ways they can do this is by working through the recipes folder. From there, they would go into the appetizers subfolder, and then they would move on to the hot folder in search of the recipe. In other words, the procedure is open a folder. If the recipe is there, you're done. If not, search each of the child folders until there are no more folders, almost like a loop. Although it seems simple, it's hard to use for in or while loops because you don't know the number of subfolders. But there's another type of loop you can use when the code for each step is the same and only the input and output changes. Recursion is a loop that happens when code calls itself. This happens repeatedly until a condition instructs the code to stop. To illustrate how recursion works, let's imagine the recipe searching process in the form of Swift code. Say you have a function called findRecipe. FindRecipe is a recursive function that implements the search algorithm. When the folder in the argument contains the recipe, it returns its name. Otherwise, findRecipe is called again with each child folder. But how does the recursion know when to stop? Well, there are 2 different ways to establish this. The first way is to find a recipe which returns the name of the folder. In recursion, this end condition is called the base case. It's very important to include a base case. If not, the program can continue to make recursive calls infinitely until it eventually crashes. The second way the recursive call ends is by searching all the folders. But there is no code to check this condition. It happens because of the way recursion works. Now that you understand how the findRecipe function works, let's break down each step of the process. Recall that you can move from the top level recipes folder to the next level appetizers, which contains the hot and cold folders. Start by calling findRecipe with the recipes folder. The file is not there, so the if condition fails. The function continues by calling itself for each folder inside recipes, starting with appetizers. Appetizers does not contain the file, so findRecipe is called for each of its folders. Hot does not contain the recipe, and it also has no folders. The call to findRecipe hot ends, returning nil. Appetizers then calls findRecipe with cold, which also returns nil. Appetizers has no more folders, so that function call also returns nil. Now there is only one active function call, the original call to search the recipes folder. It's still searching child folders, and next is main courses. This time the recipe is found and the call to findRecipe main courses returns the folder name. There is still one more recipes folder, chicken, and it does not contain the file. Checking that folder would return nil, and the whole search would fail. To prevent that, you add a conditional in the code that ends the recursive function call once the file is found. To summarize, a total of 4 recursions were called. But what if no recipe was found? The sequence of calls is almost the same except that chicken is searched after house specials. That returns nil, and since recipes has no more folders, the top level call also returns nil and the recursion ends. Keep in mind that the system uses memory to keep track of each function call. The more work a function needs to do, the more memory the system needs. In recursive functions, most of the work happens in the base case. Next, let's briefly go over the key types of recursions. The work of finding the file, the base case, happens before find recipe calls itself. This is called tail recursion. Head recursion is when the recursive call happens before the main work of the function. This usually requires more system memory for each recursive call. On a mobile device, tail recursion is usually the better choice as it's more efficient. You may have noticed that checking one folder with find recipes can result in many recursive calls. This is called multiple recursion. A function that can call itself only once is called single recursion. In this video, you came to understand how recursion works and how it differs from other types of loops such as for and while. You also became aware of the 4 general types of recursion, which are tail, head, single, and multiple.